Welcome to the BS and Beer Show. It's great to be here tonight. We are going to talk about indoor air quality and dealing with wildfire smoke and other pollutants. So this has obviously been a big deal this year. So we're really excited to get everybody on to talk about it. The BS and Beer Show is a independent grassroots movement. Everybody who's here volunteers their time. So thank you. And we really appreciate the time that you guys put in and are willing to share with us. We encourage everyone in the audience to start their own local groups, right? BS and Beer started by us meeting in person. So start your own local group. Information on how we did that is on the website. We encourage you to go there, check it out, start your own groups locally, help the movement. The chat box is probably already going off on your screen, so please make sure you pick everyone or all panelists and all attendees so all of your friends know that you're here. Say hi in the chat box, tell us what you're drinking. Tonight I'm having a nice refreshing white wine because it was like 95 degrees in Maine and felt like 103 today, so not September weather, so needed a cold beverage tonight. For those who don't know, I'm Emily Mottram. I'm an architect in Maine, and so we've been doing this for 3 years. If you don't know who I am, welcome. We love new people. The video recording for tonight's show is going to be up on our YouTube channel and on Green Building Advisor, probably by tomorrow, maybe by the weekend, so you can see all of our previous shows. And if you want to know what show is coming up, go over to the bsandbeershow.com and join our mailing list. That will give you an indicator of what show is coming up next. And last, I just want to thank our media partners, Fine Homebuilding and Green Building Advisor, for helping us make this happen every month. So thank you to them. Ben, it is your turn.
All right. Yeah, thanks for joining us, everybody. This evening, I'm drinking a Northeast Represents from Kent Falls Brewing, which is made with all New England grains. And I learned the interesting metric that 1 pint of this beer is equal to 4 square feet of grain. Well, there you go. So put that in your hat for later. So we have a couple of announcements to throw out there. Emily's Pretty Good House training series called the Sustainable Home Building Accelerator is open. We'll drop links into the chat box. The Rocky Mountain Building Science Symposium is coming up next week. You can join myself, Steve Basic, Jake Bruton, Coda Wayno, Ross Trethui as we nerd out on all sorts of things building science. Next month, you can join the exact same crew minus myself in Charlotte on October 10th and 11th. That's Charlotte, North Carolina. November 15th, our good friend from GBA and BS and Beer Show regular here, Armando Cobo, is putting together a great event in Dallas, Fort Worth for Building Science Day, November 15th. And then coming up on September 14th, our friends at Helm Construction Consulting are running an event called Building Healthy Culture in Construction. Coming up, like I said, September 14th, the intent is to create an open space for men to talk about how patriarchy and toxic masculinity affect us all and brainstorm ways to change workplace culture, specifically in the construction industry. So I encourage you to join them and check out Helm if you're not aware of them. And with that, I kick it over to Mike for some introductions.
Or thank you, Ben. Yeah, just briefly, I am Mike Baines. I'm a residential designer in Palermo, Maine. Tonight, I am drinking a Tinto de Verano, which is also called Spanish wine. It's basically what the locals drink instead of sangria. It's just wine with some Italian soda. It's really good on a 90-degree day. Joining us tonight are John Semmelhack, co-owner of the Comfort Squad in Charlottesville, Virginia. I believe formerly owner of Think Little, or was Think Little sort of merged, or how did that work, John?
There we go. We merged Think Little into the Comfort Squad in 2022.
Excellent, excellent. Do you have anything interesting tonight for beverages, or?
I stopped at our local shop to pick up a couple of singles. I've got Delirium and a can tonight. That may be sacrilege. I don't actually know, but I think this one is kind of famous or well known. Anyway, this is not local, but I do have a local backup in case I finish this one.
Nice. And
good choice.
Blake, yeah, for sure. Blake Reid, Ben and I have known forever. A fellow building nerd out on Hawaii. I believe the town is Kamuela. Is that how you say it, Blake?
Yeah, but most people call it Waimea.
Waimea, okay. And he owns Terawatt, which is insulation and energy auditing and building science consulting and all kinds of good stuff. And he is near Lahaina, where you may have heard about a little fire recently. So that sort of ties in. And then, yeah, what are you drinking tonight, Blake? And anything you want to add in terms of accomplishments or things coming up? What's going on?
I think my biggest accomplishment lately is like now drag queens are following me on Instagram. So I kind of feel like I've made it. And it's and I'm having a non-alcoholic athletic brewing company Run Wild IPA. I'll just say it's passable.
It's passable
Passes for IPA. Even if it had alcohol in it, I'd say it still might pass.
Okay. Or got it. And joining us on short notice, so she's not in our promotions, but Dr. Gail Carlson is the director of the Buck Lab for Climate and Environment at Colby College. I'll post a recent article. Dan Colbert, who a lot of you know as the father of the Pretty Good House movement, emailed to me today from Cambodia to ask if I'd seen the article and that we should invite Gail for tonight. So I emailed her and miraculously she was available. So Gail, welcome. Do you have anything interesting to drink? Do you have anything you want to add about who you are, where you are? You are muted, by the way.
Yeah, thank you so much for inviting me. Happy to join. I am a biochemist and a public health person by training, so I'm not really a buildings person, but I will say I have been collaborating for the last few years with Thornton Tomasetti, which has a sustainable design office here in Portland, Maine, working on the sort of safer building materials and the red list of toxic chemicals, trying to get those out of their building projects, especially on like college campuses. So it's a super interesting area for me. I don't drink a lot of beer at home, but I was recently in Berkeley, California, dropping my son off actually, and they had a really good brewery there called Fieldwork. So that was really good, a Fieldwork IPA. I will say out there, they had a lot of Allagash on their beer list, which I thought was kind of interesting. But anyway, I'll leave it at that.
Great. Tonight's topic is indoor air quality, specifically as relates to what wildfires. I'm sorry for anybody who doesn't know me. I do stutter. John, do I recall you might have had a few slides to share to kick things off, or am I misremembering?
Sure, I can share those. You can all see the screen, hopefully. Just a few slides. This is a slide from this map here is like 2020, and I was going to put together a map of North America and try to figure out which locations in North America have not been affected by wildfire smoke over the past 5 years. And I think we're pretty close to zero. Maybe Miami, maybe somewhere in South Texas, I don't know, but certainly just about everywhere west of the Mississippi, and now everywhere east of the Mississippi, and now most of Canada and Hawaii and maybe Alaska as well. We've all been impacted by wildfire smoke. A few years ago now, 2020, I was co-presenter and co-panelist on a few different panels when the wildfires were especially bad in the West. And here I was in Virginia feeling a little smug, I would say. Our wildfire experience was, maybe we had a little forest fire in the Shenandoah National Park, and it, was a minor 1 or 2 day thing, but pretty rare. That's more like negligence in the park, not like giant whole forest burning. And then this summer, we had 3 separate wildfire smoke incidents, anywhere from 1 day to 4 days long. We were probably not as bad as some of the other locations, but we got hit pretty bad 3 separate times. So like when New York was hit really bad, we were as well. When the Great Lakes, Chicago, Detroit, Cleveland was hit really bad, we got hit really bad as well. And just everywhere is getting it. And we already had good filtration practices, and now we're kind of bumping them up a good bit more to the next level. This slide here, this is especially for tight home builders where most of the filtration is happening through the ventilation system. This is from a paper that was published in ASHRAE Journal 7 years ago now, by Brent Stevens, Terry Brennan, and Lou Harriman, looking more at commercial buildings where they're using outside air systems for conditioning their whole building. So they're just getting one shot at filtering that outside air. And they were trying to look at, what level of filtration would it take to meet the US federal and WHO guidelines for fine particles, PM 2.5, when the outdoor air is really, really bad or crazy off the charts bad. And what they basically found was MERV 16 or HEPA is what's needed. That's the modeling study. And I think we're seeing that in real life, that the modeling holds up. Factors that affect indoor fine particles, PM 2.5, of course, we're talking about outdoor wildfire smoke. We don't have control over what that, over what the wildfire smoke is doing, but we have control over all of the rest of these: building air leakage or air tightness, ventilation rate, filter performance and bypass, ventilation imbalance, other indoor particle generation, and then filter performance on the indoor recirculation filter. So we have a lot that we can do even when we don't have control over what's going on outside. And I think I'll leave it there for now. I might come back as we get further into the discussion with kind of where we are in terms of filters, but maybe it's too early in the show for that.
Or sounds good, thanks. Yeah, in our online promotions, somebody just commented with a comment MERV 16, and I responded, we have to fill an hour of airtime. We have to go a little beyond MERV 16. There has to be more to it. Gail, maybe you could tell us a little bit about the health impacts, like beyond being an annoyance. Why do we care about wildfire smoke or other fire smoke? It may not be wildfires, it may be wood stoves or maybe leaf piles or whatever.
Yeah, sure. So, as I'm sure most of you know, both indoor and outdoor air pollution is, especially from burning wood, like wood stove smoke or wildfire smoke, is incredibly complex. So when you ask the question about what the health impacts are, it's much more than just like, oh, if you have asthma, stay inside, or, oh, your asthma might be exacerbated by a wood stove. And it's significant enough that it's really what some people call a silent threat to health, because actually just from outdoor air pollution, millions of people die every year from exposure, for deaths that can be attributed to air pollution exposure. But most of us don't know that. And most of us don't think like, oh, I live in a big city like New York and, there's a lot of air pollution and it's like slowly killing me. Or in Maine, so many people use wood stoves and it's perceived as green and even environmentally friendly and it is. And I hate to even say this out loud, but it's also got significant health effects. So somebody said something like, could PM 2.5s be sort of like a proxy for all of the air pollutants? And I would actually say no, because fine particulate matter is incredibly toxic. But there are other things that you guys probably talk about all the time, like polycyclic aromatic hydrocarbons and other volatile chemicals that are carcinogens, both in wildfire smoke and in wood smoke. And there was a study that the EPA did that actually showed that exposure to indoor wildfire smoke was actually increased the lifetime cancer risk 12 times more than the equivalent amount of secondhand cigarette smoke. But again, we don't really talk about that. I remember there was a study that I read that, because I teach a class on pollution and human health, that showed that actually brain cancers in kids in homes that have wood stoves is actually higher than kids growing up in homes without wood stoves. So there's that, so I don't think there's sort of a proxy single pollutant. I think you have these carcinogens, you have soot, which is linked to chronic respiratory diseases. It's linked to increased hospitalizations and deaths from people with underlying cardiovascular and respiratory diseases. So those are kind of the two sort of big categories that you think about, besides also ozone, which is less of an issue with respect to like wood stoves or wildfire smoke. One of the things that's interesting too, I'm thinking about it today in Maine, it was so hot and we had a moderate air day with particulate matter, PM 2.5s starting around 82 or something this morning. It's gone down to like 60 now if you look at the air quality index. But almost nobody in Maine has an air conditioner. I don't know how many people have ventilation systems. We do, but most people don't have an air conditioner. So you live by opening your windows. And these days when it's like, oh, should I open my windows? Because there's, a wildfire smoke day, or, it certainly is a trade-off as far as, health exposures. But the other thing too that I'll mention is that I think people probably appreciate the sort of cancer-causing effects of air pollutants or the respiratory effects. But air pollution generally from wildfire smoke or whatever is also associated with things we don't talk about, like adverse pregnancy outcomes, immune suppression, neurodegenerative diseases, and even mental health impacts.
Wow, so it's a big deal.
It's a huge deal, and I think we underappreciate the problem. And with wildfire smoke, wood stove smoke, it's there all winter long. You've got it in your house, you're breathing it in, you're used to it. These wildfire smoke episodes, especially in places like John, you were mentioning, that hadn't previously had problems with wildfire smoke, people think like, oh, well, it's bad for a day, but whatever, it'll go away. And we also don't appreciate that actually your cumulative risks, maybe your low levels, low level chronic exposures could also be significant. So many people were interviewed on the news after New York City turned, skies turned orange, and they were like public health professionals, and they were like, oh, don't worry about it, just stay inside today, but it's going to be fine tomorrow, that kind of thing. Yeah. And also it's very much about protecting just yourself and not thinking about solving the problem. What are the sources of these pollutants, either indoor or outdoor? It's just, well, as long as you can protect yourself, you're fine. And obviously in buildings, you guys do want to protect the occupants. So I understand that, but it's really complex.
Yeah, great. Blake, what's the current situation on Hawaii, and how different has the smoke from Lahaina been different from like the volcano smoke or other sort of normal things out there?
I'm on the Big Island, which is near Maui, but one of the things about Hawaii that was surprising was that the largest percentage of land burns every year here in Hawaii than in any other state.
No kidding.
Around 2005, there was a 25,000 acre wildfire on this island, and it got right up to a community. And last year, basically the same 20,000 acres burned. So it's wildfire season, like we're used to it. But one of the things about I hear a lot of talk about particles, because you burn things and you get particles, and breathing particles is bad. But when a town burns, everything under the sink burns too. All your cleaners, everything you were keeping around that you kept safely in the garage because it's bad to breathe, all the stuff that went into the houses burns. So it's not just gases or not just particles that you have to worry about, it's the gases too. So then you start thinking about how to protect yourself. And and when I'm blowing insulation in attics, I wear this thing with the fuchsia filters, right? Those are for particles. But you start working in cleanup, and you start having to worry about the kinds of filters you're using. some sort of organic vapor cartridge. So, but yeah, like we talk about protecting ourselves, but not everybody has these, and in houses that like typically aren't conditioned, like I heard, it's the houses don't have air conditioning. It's like, well, here, like houses don't have air conditioning either, but the climate is changing, so air conditioning is going in. But a lot of those are they're mini splits, and so they're wall warts, and they don't do anything to filter. So filtration is not something that we can really expect to happen on a consistent basis in the housing stock here.
How about, or maybe this is a question for John, how about spot ventilation with a Comparetto tube, which is also called a Corsi-Rosenthal box, but I know your business partner is Neil Comparetto, so you probably prefer that term. Are those effective? Can you tell us about those a little bit?
Yeah, so those are super effective. So the Corsi-Rosenthal box is kind of the name that's really caught on over the past couple of years.
Those are great. Like, like while you're
share.
figuring it out, like whatever you did to like to figure that out and put it out into the world. Like my brother is doing he lives in Minnesota, and he's like having a renovation project, and he's like, oh, I saw this thing on YouTube, and made them. And they're making them in Lahaina now too. It's like, but now because it's cheap and they need to clean the air around them. But it's like, so now there's a shortage of fans and filters.
Yeah, so this idea of slapping a good filter on the back of a box fan, like a $25, $30 box fan, it's probably $60 where you are, Blake. But this idea has been around for a while. I first saw this idea in a couple of presentations by Linda Wigington, and then during we're still in the pandemic, but in the beginning of the pandemic, Richard Corsi, who's an indoor air quality researcher, now I think back at Cal Berkeley, said, hey, why don't we put 5 filters instead of just 1 filter, 5 filters in a box formation on one of these box fans, and we'll get a ton more airflow because 1 filter is too restrictive. So he kind of put this out on Twitter. And I said, I think on Twitter, that's crazy. Nobody will build it because it's too complex. And let's just stick with getting them to put a 2-inch filter or a 4-inch filter on the back of the box and call that good enough. And my business partner, Neil Comparetto, said, no, it's not that big a deal. We'll make a video, we'll test it out, and we'll show how much better, because we really, he really thought it was going to be much, much better airflow, therefore more air flowing through the filters, more particles getting captured. And so we did that. He did a 4-filter version with a cardboard bottom for better stability. We didn't have a name for it. Allison Bales decided to call it the Comparetto Cube because alliteration sounds good. Anyway, we were all having fun and testing things out while we were doing less work than we normally do during the pandemic. And then friends of the show, Ask This Old House, Ross Trethewey, put it on their show, and it now has close to 1 million views on YouTube, which is fantastic. So you can see a picture there, but you can Google Comparetto Cube or fan filter box or Corsi-Rosenthal box. Rosenthal is Jim Rosenthal with Tex Air filters in Texas. I think Jim, more than anybody else in the world, probably has done the most to really promote this idea because it's so simple and effective especially for existing houses that are leaky. And they, when you've got a leaky house, you don't have a lot of control over what makes it inside. But once it's in, you can, push a bunch of air, or pull a bunch of air. In this case, you can pull a bunch of air through fairly high performance filters. And if you have good airflow and good filters, you can get really great performance. So we use these at home, even though we have a tight house. I don't yet at my house have really good filtration on my ERV, my incoming air or my outside air. So we use these at home during the wildfire events. We use these at home when somebody in the household is sick with a virus, whether it's coronavirus or something else. So we kind of have them going quite a bit.
We have one that exists full time in our home, and it just constantly sits in our living room or sometimes our kitchen, and just hums along throughout the day. And every couple of months, I build another one. One of the things that really struck me when Gail was talking about the wildfire events in New York is, I'm a person who has a Corsi-Rosenthal box, Comparetto Tube sitting in my house. I have air monitors in my house. I'm watching the air quality. I have, MERV 15 low statics on my air handler. And I'm still seeing in my house, I don't have a very tight house, PM 2.5s, going above 80. And then I'm thinking about everybody else who doesn't have any of that stuff in their house and what's going on. And then I'm looking at the media and seeing nobody talking about the health effects. And it was shocking to me. Like, we're all talking about like this great big fire, but nobody's talking about what's happening and why you should take it seriously. And I'm going to my job sites and I have carpenters all over the place. I'm like, can you guys just please put a mask on for today? Like, just do me a favor. I like you guys. Just like take care of yourselves. Like, my eyes are burning and I'm wheezing and feeling tightness in my chest just from going out and doing errands. And yet nobody's talking about this.
Yeah. I think the chat box too is kind of blown up here talking about fresh air, right? Which I think we can all agree during wildfire season that nothing about the outside air is fresh. And I've heard Allison present a number of times too now where he just said outside air is outside air. Nothing about it is fresh unless you're filtering it or whatever. But in the past, I've heard people talk about during wildfire season, turning the ventilation off and using something like the Comparetto Tube that we just saw. Have any of you done any kind of research on, like, if you're, like you said, your ERV doesn't have that great of a filtration on it, and so you run these during wildfire season. Would it have any impact if you turned your balanced ventilation system off, right? Because you're then sacrificing some other things that maybe are happening because the air quality is so bad for, a day or a week. Has anybody looked at that, about just filtering the air that we have inside with us, especially if you have a relatively tight house, versus trying to introduce air that then you need to filter more?
Yeah, I mean, that's during the wildfire smoke events for us here in Virginia, that's what we did. We did turn off our ventilation system. So it's certainly more effective at keeping the PM 2.5 outside. Our CO2 levels indoors were quite high because we do have a tight house, and so we stopped ventilating. And so that's kind of where, as practitioners, we started to pivot a little bit in terms of what we recommend and install for our clients, because we think we can, we think it's not that hard, given a little bit more space for a better filter. We think it's totally doable to actually keep ventilating even in the face of pretty bad outdoor air. With good filtration.
Or just, I want to jump in for anybody who doesn't automatically know why PM 2.5 is dangerous. Actually, it was an Allison Bales presentation where it finally made sense to me that it's particles so small that they go right through your lungs, right through the alveoli, directly into your bloodstream. So like in our pretty good house presentations, I say that garlic and broccoli may be healthy, but you shouldn't inject it directly into your bloodstream, and that's what happens when you cook. So that's or that's why it's bad. It goes directly into your bloodstream and everything that's carrying.
And the other thing about small particles is, yes, you're right, they themselves can gum up your alveoli and get into your bloodstream, but they're also incredibly sticky. So other toxic chemicals end up sticking to those soot particles. So you actually are also delivering heavy metals and polycyclic aromatic hydrocarbons and other carcinogens, even just airborne, toxic chemicals, PCBs or, other thing, think of those kinds of pollutants. It's possible, depending upon what is in your air, that those things are going straight into your bloodstream.
I guess the thing that's tough for me to wrap my head around is like, we can filter for particulates, but like when we're talking about those hydrocarbons and when we're talking about VOCs and all these volatile compounds, those are things that like we can't really remove not in a residential setting or even in a commercial setting effectively. So it's what's the best approach then? Is it to do like we're talking about and shut off our ventilation and try and control your indoor air as much as possible, or are there effective ways to manage for that stuff?
Are there data that show how much, like say, volatile organic compounds are being removed from some of these filtration systems? I have one in my house, but I don't know any of those.
Yeah, as far as I know, most of the media filters that we use, and John, chime in and correct me if you're aware of other here, but they don't really effectively remove any volatile organic compounds or SVOC compounds.
Yeah, I think that's right. To the extent that VOCs, unless they're stuck attached to a particle, then they're not going to get captured. So yeah, a lot of the chemicals just pass through. There are a couple of MERV16 filters that have a carbon coating, an activated carbon coating on the filter, on the face of the filter. So that will work for a short period of time. There are other methods where you can do a pre-filter with a larger mass of activated charcoal or activated carbon. But my understanding is that you need a significant mass in order to effectively remove VOCs from the air over an extended period of time without having to constantly replace that thin coating on the MERV16 filter.
Yeah, Ken Kiefer mentioned it in the chat. I went down a rabbit hole with this a handful of years ago. There's sorbent technologies that, like, if you have a client that's living next to a paper mill or something like that, and you know that you have a specific chemical constituent in the air, that you can tune a sorbent technology to be able to remove that, but it's wildly expensive. And yeah, to your point, John, it's a big piece of equipment to do it. So I bring up the question because I'm just not sure if anybody else has stumbled across something else that we can use in that realm, because those things are, PM 2.5s and the PM1s and all that cross the blood barrier into our bloodstream, but also like all those chemicals are, that's a huge part of the makeup of all of that. Like to Blake's point, like you're burning everything that's under the sink too. Like I don't really want to inhale burning chlorine bleach or pledge or whatever it is. So
Yeah.
Right. Yeah, I think that would be maybe there are already some research studies that kind of show actual performance for some of the different products that are available. I don't know them off the top of my head, but that's something that is definitely worth exploring some more. So not just capturing the fine particles, but also the VOCs.
Of course, the downside to filtration is the better the filtration, the more energy it takes, and so we're also trying to save the planet through our buildings. So the more you filter, the more it costs, and the more carbon release there is. Is MERV16 still the magic point? Are there different technologies that MERV16 may work with, say, a Zender, but not a Renew Air or something? Or I don't know. Blake, do you ever install ERVs or HRVs? Is that a thing out there?
No, not really.
No.
Mostly
And
just because
I was going to add to Mike's question there too, is when you're talking about the systems and the pre-filters you were talking about, is there ways to save where you put a stronger filter in a pre-filter for a short period of time and that's effect on the equipment? So I don't know, Blake, if you do exhaust only ventilation for or do you just not have any ventilation in your area?
it's
that's a thing here. So
I know I lived on the continent for a long time. It's like I think what we see here is a lot of houses like you see in a lot of parts of the country that were built in a different century, and things were different then, and there's a lot of history that goes along with them. It's like, well, we don't need air conditioning, it's Hawaii. It's like, well, like a lot of people call me because they're hot, and it's hotter this year than it was last year, and next year it will be hotter than it is now. And So the houses aren't designed to have even any place to put a system. Attics, or there are no basements. We can't run things under houses unless my house is on stilts. I'm on poles. But I have installed some equipment, mostly dehumidifiers in like parts of the islands that I live on, just because the closets get moldy. And so like the ventilation that I'm trying to like kind of sneakily build into the system is a recirculating thing that will like serve the whole house, but really focus on the closets, like to put warm, dry air in the closets. And I actually, like I got that from Ben, like a long time. I'm pointing at Ben right now. It's like a long time ago. He was like, oh yeah, the problem is the closets. And I'm like, yes. So like I try to sneak these things in periodically, and they have the filters that come with them, and typically they top out at 13, MERV 13, which is still better than some others. But also these places, the wet and moldy places, where I put these in, they're upwind of the wildfire areas, so we hardly ever get smoke up here. So when we do, it'll help to catch some of it, but also the houses are not very airtight. I tested one today and it tested up over like almost 8 ACH 50. So it's something that's coming. Airtightness rules are coming. So are the fires.
To your point there, Blake, about dehumidification, that is incredibly important in controlling the indoor air quality in your house, because if we have lower humidity levels, we have less chemical interactions that are happening in the air between all of these compounds that are floating around in the house, and there's less energy available for them to mix together and go into solution, form some other kind of chemical stew. An eye-opening thing for me was when home chem really started getting going. What is that? University of Texas. They started doing some tests, and they were finding out that it wasn't so much the chemicals in the house, but it was the interactions between the chemicals that was creating the really bad stuff. It's your spray on hairspray combines with the stainless steel cleaner in the air, and then all of a sudden now you have something that's really nasty. So if we can remove moisture from the air, we give less opportunity for all those things to kind of mix together and make really gross stuff.
Yeah, and I think for like a lot of us as practitioners, like it's like architects and contractors and designers and home performance contractors and HVAC IAQ contractors, like I think we try to, like, there's a lot of stuff that happens like behind the scenes to try to like sneak in some like little like upgrades and touches, and but we can really only touch one house at a time, and it's like, but it's good to try.
I think you brought up an interesting point there, though, is there are a lot of things that happen behind the scenes, like as in after we leave, right? And Ben is talking about the chemical soup and everything too. There was something in the chat box that I caught earlier too about talking about what then ends up in our ductwork too, right? So is there, like, what do we do about the potential for some of this stuff to remain in the systems afterwards? Like, have you guys had any kind of experience with, like, does it matter, like, not where the filter is, but obviously where the filter is too, right? If you can keep it out of more of your ductwork or whatever, are you seeing an impact of that?
I don't know if we're seeing an impact yet, but I think just intuitively, if you can stop it before it gets into your house, that's the best situation. So, ideally you have a tight house, so you have very little coming in through air leaks, and then you're filtering before it hits your ventilation fan, your ERV or HRV, whatever you're using for your ventilation system. I think this is also a good time to talk about exhaust only ventilation, because exhaust only ventilation is you're not going to have control over your filtration. You may get kind of a MERV 11, I think I've read, effective filtration for most of the airflow pathways through your house. for that, you know.
I'm dubious of that one.
Yeah,
but
I'm like, that sounds
no, I
pretty
think
good. I don't know about that.
No,
It's an average.
Yeah, no, I think the indoor air quality researchers have actually tested that out, but MERV 11 is still not that good. I mean, when you're dealing with wildfire smoke, MERV 11 is, you know, nowhere near good enough. So just, you know, MERV 11 here. Oops. MERV 11 in terms of PM 2.5 particle removal, you're getting 20% of the hardest to capture particles. That's just not, you know, that's not good enough. So we need something, you know, really something that's up in here, MERV 16 or higher. For what it's worth, what we're doing with ERV systems is this here. So this is most of the ERV systems, the box, just the manufacturers don't make the box big enough for an effective, really high performance filter that also isn't a big energy waste. So if we're trying to like balance that, you know, year round energy use and associated pollution, carbon emissions, et cetera, with the, you know, short-term particle removal, right now the manufacturers, they don't really have good options. So like Renew Air has a MERV 13 optional filter. MERV 13 just isn't good enough. I think Zender has what's equivalent to like a MERV 14 option or filter, which is a step up, but still not quite good enough. And so what we're doing now is a MERV 16 pre-filter box, and you can see this is like a 5-inch wide filter, so it's like a 20 by 16 or 20 by 20, depending on which one we're getting, by 5-inch deep filter. And then that's going into a box so that we can have smooth airflow going into the filter and coming out of the filter. And the box winds up being as big or bigger than the ERV, which is kind of wild for the space constrained, or as Blake was talking about, really wild idea for houses that were designed for near zero mechanical equipment. So it definitely takes some planning. In this particular case, we had an attic to work with, so it was easy. But it's going to be I think a difficult thing to retrofit in a lot of situations, and I think designers need to plan for some extra space to accommodate these bigger filters. But what we're able to do here is we've got a giant filter that's kind of made for filter, you know, for letting, you know, over 1,000 cubic feet per minute of air flow through it with minimal pressure drop, and we're only moving 100 through it. So the pressure drop is almost nothing.
Click on the other picture. It's still showing your MERV graph so that people can understand what you're talking about.
Let's see. Can you see it now?
Oh, we still see your MERV graph, your chart.
Oh.
There it is.
There you go. That's pretty.
This is it. Let me click play again. Yeah, so this is, yeah, so now you can see here's the Renew Air ERV. Here, this is the, you know, 5 by 20 by 20 or so MERV 16 filter. This one is the Lennox model with the activated charcoal coating. April Air is another one. You know, so these are like off the shelf kind of products readily available. But we're putting that into a box so we can have smooth airflow into the filter and out of the filter. So the filter is really doing its thing, but it's really just as big as the ERV. So it takes up quite a bit of space.
John,
But
is that a function of the fact that the ERVs just can't handle the static levels, and you need the largest...
Well, they could. So it's true. We're trying to get the best of both worlds. We're trying to give MERV 16 filtration while still having the energy performance of the factory MERV 8 filter. And in order to do that, you need a really big MERV 16 filter. So that's kind of what it takes to have the best of both worlds. If you don't mind the extra energy use, yeah, you could probably figure out a way to do a smaller filter. But it is challenging to like find the smaller, smaller MERV 16 filter or smaller HEPA filters that are for like residential scale stuff. So for now, we're focusing on what is readily available off the shelf products from the bigger manufacturers, that are they're relatively inexpensive and not that different than the similar construction MERV 13 version of the same product. It's just a little bit more price, a little bit more money for the MERV 16 option versus the MERV 13, and then we can do it.
That was actually something I was going to say, because someone recommended this to me recently, because it's actually cheaper to buy those filters than the replacement filters that you need for in the ERV itself, right? And so people are more, maybe more willing to change those filters when it's something that it's readily available that they can pick up off the shelf versus having to call.
Maybe these are like in the $100 ballpark for the replacement filters.
Right, but if you went to a similar MERV filter for in your actual unit on the smaller,
right, then it would be
and
like a special size.
Yeah,
yep,
exactly.
Yep.
So sorry, that wasn't exactly clear.
No, I get it now.
We need instead of wimpy ECM motors, we need like diesel powered ERVs to really pull that air through. Like,
it's either that, and like Emily was saying, some practitioners that I've talked with on the West Coast, they're kind of doing retrofits, and it depends on the amount of space that you have. Some are doing retrofits in very small spaces, and so they're constrained to the filter size, and so then they're doing like they're putting their house into wildfire mode for hopefully a short period of time, but putting it in wildfire mode, sucking it up, it's extra energy use, but they're putting in like a temporary HEPA filter or MERV 16 filter, and increasing the fan. If it's a self-balancing ERV, the machine will increase the fan power to keep the airflow going, or they're doing that manually if it's a manual thing. But yeah, if you've got the space, then that's kind of what we look at. If we have room, then let's do the best of both worlds.
I was wondering if I could make a quick comment, and I think, Mike, you alluded to it, but this is obviously your industry and this is what you guys do, but all of this stuff is expensive. It takes energy, just thinking about everybody needing air conditioners now because it's hotter and hotter, and that contributes to greenhouse gas emissions. And the health effects of environmental determinants like wildfire smoke, air pollution, indoor, poor air are not distributed equally across the population. And just like everything else, it's people who can't afford these, changes to their homes or whatever, or, maybe don't have the means to, remediate a mold problem or whatever. And they end up, facing the health consequences. And we're not even really kind of recording that or measuring that, how people who can't afford these things probably are exposed at higher levels and probably face, the adverse health effects. And, children are particularly vulnerable, if they're exposed in childhood to a lot of these things. They're, they could have permanent lung dysfunction. So, I think about like how, I know it's not really what your industry does, but how your industry thinks about those disparities and that lack of equity in terms of everybody being able to access clean air. And certainly it does argue for changes at the policy level to just get rid of, things that have volatile chemicals in them, or tackle climate change so that we don't have, the worsening air pollution or wildfire smoke. But I'm just curious if anybody wanted to comment on that.
I can. Something I hear a lot. It's like, oh, like it doesn't cost a lot. It's like, oh, just a little bit of energy. It's like, oh, just run your fan a little bit more. It's like, well, like it's 50 cents a kilowatt hour here. Like $1 will buy you 2 kilowatt hours. And that is real money in a place that, has a pretty, like, let's call it it's a high cost of living. After the Lahaina fire, the word on the street is that the utility is getting sued because they probably started the fire. We don't know, but everything's pointing in that direction. So that's going to be a lot of money, and they're not going to pay for it. Like, they're going to raise the money from everybody who gives them money already, which is me and everybody else. So the word is that, like, the cost of a kilowatt hour could jump 50%. So we could be looking at like 75 cents a kilowatt hour. And the people who like are already struggling, you know, like in like multi-generational families, it's like we'll just struggle more. And so I hear you. So, but also like yes, it's like, you know, that costs a little bit of energy right now. But in 10 years, like, how much energy are we going to be spending on filters and kilowatt hours and, like, you know, recirculating the air and, you know, and the gas that we need to get away from wildfire zones? It's so I hear you. It is a big deal.
We're talking about, you know, we're talking about the bandage to the situation here. We're not talking about the cause of the situation here, which is what we really need to be addressing. I read something a handful of years ago, and this is kind of related. The guy Thomas Midgley, who's the man who invented Freon CFC refrigerants, he's also the man who invented leaded gasoline. And if you total up the number of deaths caused by leaded gasoline and catastrophic climate change from refrigerants, he's killed more people than any single human that's ever walked the earth. And that leaded one is pretty close and near and dear to me. I live about 20 minutes north of New Haven, Connecticut. Many people here are probably familiar with RRP, the Lead Remediation Act that contractors have to deal with. That started after a study found that children in New Haven, Connecticut have the highest lead levels in their bloodstreams of anywhere in the country. It was the result of all the pollution blowing onto us from the New York metro area through the 40s and 50s and depositing in these low-income housing areas, and nobody was ever cleaning it. So these kids were getting exposed to all of this lead dust and ingesting it. So, Gail, to your point, exactly, it's the people that have the least means to be able to affect a positive outcome that are going to be the ones hardest hit by this. And, you know, Blake, to your point, yeah, like, we all want to believe that, like, we're going to make high performance houses that cost the same as normal housing. We need to stop that. Like, that's not a thing. Like, as much as I want to try and think that that's a thing, the work that we do to create these high performance systems costs more, period. End of story. But what we all need to be doing is practicing rigorously to find ways to do it at the lowest cost possible and as simply as possible, so that we can try and all get out here and share it, and other people have as best of a shot as we can come up with at the moment to have some sort of change.
For sure. Or so what's the one most effective low cost thing you can do? Air sealing, some basic air sealing, some different equipment, a window fan with a filter in it. I used to use that when I had a spray shop. I just had a box fan with the furnace filter in front of it, and you know, that sort of worked. I'm still here.
I mean, for most folks, I think the Comparetto Tube Corsi-Rosenthal box is kind of it's the sweet spot in terms of really effective, fairly easy to build, not that expensive, lasts a while, like at least 6 months before you need to change the filters, maybe 12 months, and we're talking continuous runtime. And that's also considering that most people are living in leaky houses without an actual ventilation system. So it's not like they can add on a MERV 16 to their ERV. Like, what it, you know, most people, what's an ERV? What's a ventilation system? You know, most people, you know, 99.9% of houses probably in North America don't have that kind of thing. So yeah, for the everyday person, like the doing recirculation filtration indoors is really effective. Yeah.
For me, it's air sealing at the time of construction. It's the best time to do it. Look at all the heads nodding. Oh, good.
I was gonna say,
yeah.
or the end of usable life, right? When you're doing a renovation and you have the opportunity to air seal.
It's the best time to upgrade is when you're doing something else already. It's like, but then after that, it gets more complicated. So it's my 2 cents.
Yeah. Yeah. What's your best tip for a relatively affordable improvement, or just improvement in general? What's the one thing you'd wish everybody would do?
Yeah, I mean, this isn't my area. So, you know, when our guy came and said, oh, you need a Venmar ventilation system, we just went, okay. And you need these filters. We went, okay. And then he did say, by the way, turn it off if there's a lot of outdoor wood smoke pollution in the winter, because that's such a common thing. And wood smoke pollution, so in the winter, wood smoke pollution is so localized. But anyway, you know, this isn't really related to wildfires, but I mean, everybody should test for radon. So,
yeah, for sure. Or mentioning Venmar makes me think you probably hired Bo at the Breathable Home for your
yeah, yep. when we insulated our house and we had Revision Energy put in a like solar hot water system at the same time, which I know they don't do that much anymore, but they did whatever 13 years ago. But, and I guess I'll also just say, and hopefully this isn't controversial on your show, but like, let's tackle climate change.
Oh yeah, no, we're all about climate change.
That's not controversial here. You can say those things here.
Yeah, there's
I'll
so
say the
many.
controversy is that we've moved past calling it climate change. I call it like I'm steadfastly onto the climate crisis.
Oh, absolutely. I
like
just
we're not,
actually,
like it's already changed.
Book.
So
I just wrote a book, Human Health and the Climate Crisis. So
hey,
area on that terminology.
Hey, where's Travis when you need to know what's our next book club book?
Right. Well, I meant to mention at the beginning of the show our upcoming shows next month. We'll talk with Nikki Kruger about dehumidification. In November, we'll talk with Gary Klein about hot water distribution. Not sure about December. In January, we'll talk with Sharon Halpert about fire safety in general. So sort of a part 2 to this one. And that's all I know for now. I hope everybody in the audience comes back, and I hope our guests come back either on screen or off. And thanks a lot for joining us tonight. This was a lot of fun and good conversation.
Yeah. And I think everybody in the chat box who's measuring things, right, share that data. I really feel like that's one thing Gail brought to the table today is I think you've done a lot of data research, right? So not necessarily in our world, but like, let's start sharing that data, right? That's how we, kind of help move things forward. So thank you to everybody in the chat box who was throwing in your 2 cents. I might have to save it tonight because you guys were a little bit wild. So there was a lot going on. If anybody wants the chat box and you can't save it on your end, just let us know. It gets saved kind of on the back end as well. So thank you for joining us. Thank you to all 3 of you for sharing with us tonight. I appreciate